This is why we should be careful about the excavation and extraction of marble, in which way we destroy our mineral resources. Now, the thermal behavior of marble is that if you have a calcite marble, it decomposes at 900 degrees centigrade into calcium oxide and carbon dioxide. But if you have a dolomite marble, then it goes first to at 760 to calcite and magnesium oxide, and then to calcite, and goes to that. Now look, when you have no magnesium, it goes at 900 degrees Celsius. But when you have magnesium there, then the second alkali usually bring the fluidic nature into the material. It enhances the reactivity of the initial ingredient. Yes, these are the applications which all of you know. Yeah, what we did, we investigated 22 samples from Guner, Sawabi and Naushera. We made 10 sections for optical microscopy. We did X-ray crystallography of this material, scanning electron microscopy, energy dispersive X-ray electron spectroscopy, and transmission electron microscopy, and various physical properties and mechanical properties. Yeah, these are the general ordinary camera images of the sample. Next please. Here you look that when we do it, polarized light micrographs of 10 sections of this material, then you see what sort of twinning is occurring inside the crystallization and recrystallization of material, and then by scanning electron microscopy we look into the various parts and we know about the composition. I will discuss this at the end. Yeah, we did X-ray of this material and we found that it contained calcite, dolomite and muscovite. Muscovite is a clay, and usually quartz is coming in these materials. And I have my personal experience that if you have a calcite marble sample and you are making a transmission electron microscope sample for them, it may go up to the 20 nanometer thickness within a few hours. I mean 3 to 4 hours. But if a quartz grain comes, then it takes more than a month. So this is the difference between the complexity of phases inside the material. So when in the nearby environment you have other phases, there may be muscovite, there may be kaolinite, there may be pyrite, and a large number of phases may be present. But what we found in this material, at the left top corner you see these are X-ray of representative samples from Guner, and they have the calcite, dolomite and muscovite phases, and you can know the proportion of these phases from the area under the XRD peaks. Yeah, this is XRD of B6 marble. Again, when I say B6, this means it's Guner marble. When I say N, it is Naushera marble. When I say S, this is Sawabi marble, and Sawabi marble from Tarakur Bando, it is there. It contains dolomite and calcite. This is the Naushera marble, which contains calcite, dolomite and quartz. Next please. Yeah, this is Sawabi marble. It is mostly calcite, but we selected that sample. Otherwise, I have seen many samples with many silicate phases inside that, and they make them tougher and tougher. So for working, they are not useful when people want to make some decorative pieces from them. But for tiles or mechanical application, they are excellent. Yeah, what we did chemical analysis of these samples, and if you look, the B7 is basically the Bampoha marble, which has the highest calcium oxide content. And the highest calcium calcite content means Then apart from use as a dimensional stone, you can use it for highly technical application as well, because calcium carbonate, when it is 99 plus purity, then we buy it for several thousand rupees for a few hundred grams. So it is useful for highly technical ceramic as well, as we are having calcium titanate as the perovskite, the parent perovskite phase, and for telecommunication devices we need such calcium as raw material if we can upgrade it to that level. But secondly, it is considered the best in order to for workability, that how we develop various decorative appliances from these materials. Secondly, softness and hardness comes from magnesium content and the silicate phases, the grain size and mutual orientation. As the microstructural experts are interested only in seeing microstructurally that whether the crystals are oriented differently or in the same direction. The grain size is smaller or larger. The grain size is homogeneous or heterogeneous. So that heterogeneity, homogeneity and all these things define the level of applicability of a specific marble. And their composition tells you that how much calcite content is there and how much useful a marble is in the local market, and its polishability and shinability is defined by the calcite content. Yeah, if you look into these, the C image basically give you the granuloblastic texture. The top two are homogeneous and the M shows the muscovite, the P indicate pyrite, and pyrite, most of you know, it is iron sulfide content inside that, right? Yeah. If you look here, we have dolomite. There you have quartz grain. So as I told you, that if you have a quartz grain, then it makes your sample preparation very, very difficult. Similarly, you have dolomite phase. When you have a dolomite phase, this means you have a richer magnesium content and its scratchability. Scratchability is basically when you make samples from these materials, you use iron beam thinners. Iron beam thinners are argon beams which scratch, which skip the surface of the material. So if the surface is of a magnesium containing phase or a quartz, it will not be skipped in an easy manner. But if it is calcium oxide, then it can be easily done. So you see here the grain morphology and the connectivity of grains. Yeah, you see here these cracks come from several origins. Origin of crack is different. When a material is crystallized or thermally transformed under a very high pressure at high temperatures, in the neighboring a large number of phases are forming. For example, I studied the thermal expansion mismatch in bone china. You have tricalcium phosphate phase and you have hydroxyapatite phase. One has approximately 2 thermal expansion coefficient and the other has 4 or 5. So one expands very largely and the other expands very smallly, and you see minor cracks inside those samples. So during the processing, cracks may occur. During the blasting, micro cracks may occur, and these micro cracks destroy, deteriorate the quality of marble, and that is why it is always suggested and proposed that our marbles are not extracted in a scientific manner and we destroy the resources because of that mine. This is, if we may, where the composition contrast is depicted onto the picture. Yeah, next. There, the more patterns, this is the transmission electron microscopy, and you see the 10 nanometer length. So, internationally, people have made their materials, their minerals precious because they look into the material, not into the money, but into the material at atomic scale. A marble may be useful environmentally for kitchen topping. It may be useful for floor tiling, but it may have very highly technical applications. In the 2 decades ago, people were focusing upon high dielectric constant for resonators, for wireless telecommunication devices. But during the last 2 decades, they focused upon the magnesium silicates because they need very small dielectric constant but very high frequency response. The signal is not propagating, is not required to propagate too much inside the material. So if it is not propagating inside the material, this means you don't need high dielectric constant, but you need very high frequency response. So magnesium silicate dolomite, I am using it as a marble, but internationally it is used for very highly technical devices, and that is why it is important that we should focus upon developing our labs to such a level so that we compete with the international market. Their product is coming from those laboratories. If you look into the European society, it is the product of their university. If you look into the European product, it is the product of their laboratory. It is not the product of their mountain. I have told it clearly in several speeches that if a mineral wealth could make a nation rich, Africa would be one of the G7 countries. Africa has gold in their mines, but they are the poorest people. Why? Because they don't have the technical and the scientific skill to take their product in the highest quality to the relevant market.